Unit 5, Lessons 4.2 and 4.4, the unit circle, that symbol means circle, and the trig functions. There are 6 trig functions on a unit circle. They are defined as if the terminal side of theta intercepts the unit circle at a ordered pair xy, then the value of sine, S-I-N-E, which we abbreviate as S-I-N, that is not sin, there is no sin in math. Sine theta is equal to the y-coordinate. Cosine theta is equal to the x-coordinate. Tangent theta is equal to the y-coordinate divided by the x-coordinate, which is the same thing as sine over cosine, and that goes back to here because sine is y and cosine is x. And then cosecant, secant, and tangent would be the reciprocals of all of those. Cosecant is the reciprocal of sine, so that would be 1 over y, or 1 over sine. Secant is the reciprocal of cosine, so that would be 1 over x, or 1 over cosine. And cotangent is equal to x over y, because that's the reciprocal of tangent, which is the same thing as cosine over sine. Okay? Pause this and write this down if you need to. I'm going to move on and show you how to work some problems using those formulas. So we're going to use those formulas to evaluate the 6 trig functions of each of these angles. Your 60-degree angle. Well, the first thing you're going to do is you're going to know, because you're going to memorize your unit circle, you are going to know that the 60-degree angle on your unit circle intercepts the ordered pair 1/2 square root of 3 over 2, where this is your x-coordinate and this is your y-coordinate. So if you know that, then what you can do is you can say, well, the sine of 60 degrees is the y-coordinate. The cosine of 60 degrees is your x-coordinate. The tangent of 60 degrees is what you get when you divide your y-coordinate by your x-coordinate, so square root of 3 over 2, divided by 1/2. You can simplify that by multiplying top and bottom by that common denominator of 2. The 2's cancel. So you're left with square root of 3 over 1, which is just square root of 3. And then cosecant, secant, and cotangent would be the reciprocals of those. So cosecant of 60 would be to flip this and make it 2 over the square root of 3. Secant of 60 would be to flip this and make it 2 over 1. And then cotangent of 60 would be to flip this and make it 1 over the square root of 3. And yes, we are going to simplify these radicals. So this becomes 2 square root of 3 over 3. This is just 2, and this is square root of 3 over 3. And it is just that simple. So if you know your ordered pair, then it's no biggie. You can figure out the rest. Okay? 180 degrees. Well, that ordered pair is -1, 0. So again, your sine of 180 degrees will be the y-coordinate. Cosine of 180 degrees will be your x-coordinate. Tangent will be what you get when you divide sine divided by cosine, or y divided by x. And that simplifies to be 0. And then cosecant, secant, and cotangent is what you get when you flip those. So if I flip 0, well, that's like a 0 over 1. So if I flip it, I get 1 over 0. Well, you can't have 0 in the denominator, so that becomes undefined, which is okay. Some of these trig functions for some of the angles will be undefined, simply meaning there is not a value for cosecant for that angle. Secant, we're going to flip cosine. Cosine is a -1. That's like it's over 1. So 1 over -1 is going to give us -1. I'm waiting for this little circle to stop spinning right here before I can write this. Lovely. So, y'all having a good day while I wait for this circle? Can y'all see this circle on the video? It's that little circle of death that sometimes happens. I call it the circle of death that comes up on your computer when it just wants to spin for a little while. But it's being very annoying today. Okay, so -1 divided by 1 gives us -1, and that's okay. Sometimes the secant and the cosine, they'll be the same value, no problem. Okay, cotangent, well, we're going to flip 0 again, and we just figured out if we flip 0, we get something that is undefined. Okay, now for angles that are not in the first quadrant like those two were, or on an axis, then we're going to use what we refer to as a reference angle and ASTC, which I'll explain that in number 5, to determine the values of the 6 trig functions. But let's talk about a reference angle first. A reference angle is an acute, positive angle that is formed by the terminal side of an angle and the horizontal axis. So if you look down here, I've drawn 4 different scenarios of reference angles, one scenario for each quadrant. If you're in the first quadrant, no reference angle is needed. RA stands for reference angle, because all angles there are already acute and they're already positive. Second quadrant, to find your reference angle, you can do 180 minus theta or pi minus theta if you're in radians. And then if you're in the second quadrant, let me bring that down. The third quadrant, then you can use the formula theta minus 180 or theta minus pi to find your reference angle. In the fourth quadrant, you can use 360 minus theta or 2 pi minus theta. Now, you can memorize those formulas if you want to, but really what I like to do is just think about it. A reference angle is just how close are you to the x-axis. Like, suppose here that theta was 135. Okay? Well, to get to my x-axis, I would have to go 45 degrees more. So my reference angle would be 45 degrees. And a lot of times we use this little notation of theta prime, P-R-I-M-E, that little accent mark. We'll call it theta prime to mean the reference angle. So really your reference angle is how close to the x-axis are you. And that way you don't really have to memorize formulas. And see right here, and I drew that arrow going the wrong way. I didn't want it going that way. I actually wanted it going the other way. So let me fix that before you copy it down. Yes, I wanted it going this way. Now it's a third quadrant angle. So anyway, let's say that this is theta. Fix that. Okay. And let's say that theta is at 240. Yeah. Okay. Let's say that theta is 240 degrees. Well, how far away are you from the x-axis? Keeping in mind that the x-axis is 180 degrees. Well, you would have to go 60 more, wouldn't you, to get to 240? And again, you can figure that out by saying 240 minus 180. But again, if you don't want to learn a bunch of formulas, just think, well, how far away am I from the x-axis? Okay. Here, let's say that you're at 330 degrees. Okay, so you're over here in the fourth quadrant. Again, ask yourself, how far do you have to go to get to the x-axis? And you would have to go 30 degrees more. So that is your reference angle, or you can use this formula. Okay. Now, let's talk about ASTC. All right. ASTC shows us which trig functions are positive. And it's just a little trick that we use. But what it means is the A tells us that everything in quadrant 1 is positive. So in other words, all of your trig functions are positive. In quadrant 2, sine and its inverse, which is cosecant, will be positive, okay? That's because your y-coordinate is positive. So sine is positive. Notice that sine is positive in both the first and the second quadrant, okay? But these are the only 2 trig functions that will be positive in the second quadrant. The other 4 will have a negative value. In the third quadrant, tangent is the trig function that is positive, as well as its inverse, cotangent. That's because tangent is y divided by x, or sine divided by cosine, and they're both negative here. Negative divided by negative gives you a positive. So tangent and cotangent are the only positive trig values in this quadrant. The rest of them are negative. And then, of course, the C stands for cosine and its inverse, which is secant. Cosine is positive, and its inverse would be secant. All the other 4 trig functions will be negative. So again, ASTC tells you which trig functions are positive. All of them are positive in the first quadrant. In the second quadrant, only sine and cosecant. The other 4 are negative. In third quadrant, just tangent and cotangent, and in the fourth quadrant, just cosecant and secant. Now, the way that we remember ASTC is by quadrants. A is quadrant 1, S is quadrant 2, T is quadrant 3, C is quadrant 4. And we use the little acronym there, and we just simply say that all students take calculus. Yes, they do. Don't you dare disagree with me on that. Okay? So, all students take calculus, ASTC. All students take calculus. All right? Now, let's see how we're going to apply ASTC to find some trig values. And remember, ASTC simply tells us whether the trig value is positive or negative. Okay? The ordered pair will give you the absolute value of what those trig functions are. Okay, so let's say that we're looking at the cosine of 300 degrees. Again, use your reference angle. How far from the x-axis is this? Well, it's 60 degrees away. So our reference angle is 60 degrees. Okay, and I shouldn't put an equal there because their cosines may or may not be equal. Okay, but the cosine of 60 degrees, what I'm going to do is I'm going to say, well, that ordered pair for 60 degrees is simply going to be 1/2 and the square root of 3 over 2. And this is why you need to know your unit circle. And if you just know the first quadrant, then ASTC will help you figure out everything else. Speaking of, now let's do ASTC. Let's think about, well, which quadrant is 300 degrees in? Is it in the first one, the second one, the third one, or the fourth one? Well, 300 degrees is in this fourth quadrant right here, right? So I can expect cosine and its inverse to be positive in this quadrant, and everything else will be negative. So if I just want to find, it says evaluate the 6 trig functions. Okay, I'm going to show you how to do all of them, not just cosine, and not just cosecant over here. Okay, all right, so let me actually back up and just not put anything here. Okay, so let's do this. Let's say that this is our reference angle. So our reference angle is 60 degrees, and this is its ordered pair. And again, 300 is in the fourth quadrant. So I know that cosine and secant will be positive. Everything else is going to be a negative. All right. So go through and figure out what your trig values are going to be. Okay? And again, I know that cosine and cosecant will be positive. Everything else is going to be a negative. So I'm going to go ahead and put those negatives right there. These will be negative values, and the others will be positive values. Okay? And again, the sine is my y-coordinate. The cosine is my x-coordinate. The tangent is y divided by x. So those 2's are going to cancel out. Cosecant is going to, I'm so sorry, I did something. No. Yes, I did something wrong. It's secant that is going to be positive. Cosecant is going to be negative. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And tangent is the reciprocal of... Ooh, I think I'm trying to go too fast. There we go. Cotangent is the reciprocal of 60. Okay? And you do want to know what these are with rationalized denominators. Okay? And that's all there is to it. Okay? We'll do another one. Let's do 225. Again, let's think about, what is your reference angle? How close to 180 is this? Well, it's 45 degrees away. That's how close to the x-axis it is. Pick out your ordered pair for 45. Square root of 2 over 2. Square root of 2 over 2. Okay. Decide which quadrant 225 is in. It's in the fourth one. That means tangent and cotangent will be positive. So we'll write our little list. Okay, and tangent's the only one that's positive. That means sine, cosine, cosecant, and secant will be negative. And sine is your y-coordinate. Cosine is your x. Tangent is your y divided by x. That's a positive 1. Cosecant, we're going to flip sine. Secant, we're going to flip cosine, and cotangent, we're going to flip tangent. Rationalize these denominators right here. And we get the same thing right there. Okay. All right, now, for negative angles and angles larger than 360 or 2 pi, use the smallest coterminal angle. So find that coterminal angle first, and then you can figure out all those trig functions. Okay, so remember from the yesterday's lesson or the first lesson, to find your coterminal angle, you just either add or subtract 180. Since this is negative, I'm going to add 180, and that gives me 30 degrees. Well, that's already acute, and it's already a positive. So this is my reference angle. Okay? And what I'm going to do is, again, I'm going to figure out which quadrant negative 210 is in. Now remember, negative angles go this direction. So that actually, negative 210 is actually in the second quadrant. It's a quadrant 2 angle. Okay? And my ordered pair for 30 degrees, which is my reference angle that I'm going to use, is going to be the square root of 3 over 2 and 1/2. So again, to find the sine of negative 210 and cosine, I'm going to do the same thing that I've been doing. I'm just going to list all my trig values. And the good thing about your homework is sometimes it just asks you, like what's the tangent of negative 210? Or what's the secant of negative 210? You don't have to do all 6 of them. So I'll read your directions. Pay close attention to what they want you to find. Okay? But again, since I know that I'm in the second quadrant, I know that sine and its inverse cosecant will be positive. Everything else will be negative. So go ahead and put that negative sign. And then, okay, sine is going to be our y-coordinate. Cosine is that x-coordinate. Tangent, we're going to divide these out. The 2's cancel. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. And then I'm going to go back and rationalize any denominators that need to be rationalized. It's easier for you to just go ahead and do all your flipping and stuff before you rationalize denominators. That way you don't have to do double work. Okay? Okay, so I think you're getting the hang of this. So let's not do all the trig functions. Let's just do one or two of them, okay? Just to save a little bit of time here. But again, 450 degrees, that is more than 360. So I'm going to find a coterminal angle by subtracting 360, which I just did that one totally wrong because I added 180. I'm going to have to go back and change that in just a second. Y'all bear with me, okay? But if I subtract this, then what I get is 90 degrees. Well, this is a quadrant angle because 90 degrees is found right here. There's your 90 degree angle, okay? And they don't have reference angles. You just go with their ordered pair. That is 0, 1 is that ordered pair. And so if you want to find the sine of 450, then that's just going to be your y coordinate, and then cosine is going to be your x-coordinate, and then of course tangent is what you get when you divide sine by cosine. In this case, that's going to be undefined because 1 over 0 is undefined. And then you can find the rest by flipping. Let's fix this. I just realized I did that wrong. I'm sorry. I probably thought I was crazy. Let's see what we're going to have to do here to fix that. That is, all right, we're adding 360, so that's actually going to be 150. Okay, but our reference angle will still be 30 degrees because 150 is 30 degrees away from 180, away from the x-axis. All right, so we're in luck here. We don't have to fix much of anything here, all right, but we did need to fix that. So make sure you fix that in your notes, okay? I apologize about that. But your reference angle is 30. This angle still terminates in the second quadrant here. And then this is the ordered pair for 30 degrees that you're using. So your sines and everything are the same. So we're good now. We got everything fixed. Okay? All right. What if you have radians? Well, the same thing. Just know that, if you're in the first quadrant, which this one is, okay, that's a first quadrant angle right there, okay, then you don't have a reference angle. You can just use the ordered pair, which is square root of 2 over 2 and square root of 2 over 2, and pick up all your trig functions there. So let's say that I just want the cosecant of pi over 4. Okay? Well, I know that my cosecant of pi over 4, that's the inverse of sine. And if sine is square root of 2 over 2, then cosecant would be 2 over the square root of 2. And then I would just rationalize that to figure out that cosecant is simply the square root of 2. Okay? Now, if you're not in the first quadrant, and this is when you've got to recognize those radians, you've got to recognize this is not in the first quadrant. Okay? A couple of hints here. First of all, if your denominator is 6, then your reference angle is pi over 6. And the ordered pair for pi over 6 is square root of 3 over 2 and 1/2. Okay, second thing, know which quadrant you're in. Okay, I know that 7 pi over 6 is more than pi, just a little bit more than pi, because pi with a denominator of 6 can be written as 6 pi over 6, right? And 7 pi over 6 is just a little bit more than that. So I know that I'm in the third quadrant. I'm in quadrant 3 here. And that'll tell me what signs to use here. So like if I, the SIGNS, so like if I wanted the sign of 7 pi over 6, then that would be the y coordinate. You know, if I wanted the cosecant of 7 pi over 6, then that would be the reciprocal. But I would have to pay attention to the SIGN, the signs, the pluses and the minuses. I know that in the third quadrant, that my cosine and my sine are both negative. So both of these would have to be negative right here. If I were to go to find the tangent, then I would just divide these two out. And in the third quadrant, I would remember, oh, tangent is positive, so I'm going to keep this as a positive. Okay? All right. Negative angles and angles larger than 2 pi. Find that coterminal angle. Take negative 4 pi over 3 and add 2 pi. Got to get that common denominator right there. That's 2 pi over 3. Okay? Your reference angle, if your denominator is 3, then your reference angle is going to be pi over 3. Now, your ordered pair for pi over 3. Your ordered pair for pi over 3 is 1/2 and the square root of 3 over 2. Know which quadrant negative 4 pi over 3 will be in. Okay, so you're going this direction. Well, if 2 pi over 3 is a coterminal angle and 2 pi over 3 is in the second quadrant, then that means negative 4 pi over 3 is going to terminate in the same place, because that's what coterminal means. They terminate in the same place. All right, so to figure out, let's say we want to know the cotangent of negative 4 pi over 3. Well, I know my formula for cotangent. Okay, so for 11 pi over 2, okay, if you're not sure if that's bigger or smaller than 2 pi, then remember that 2 pi with a denominator of 2, okay, would be 4 pi over 2. So 11 pi is a whole lot bigger than 4 pi. So if you subtract 2 pi from that, okay, then that's 11 pi over 2 minus 4 pi over 2. Well, that gets you to 7 pi over 2. Just keep subtracting 2 pi, which is 4 pi over 2, until you get something that is on your unit circle, okay? A coterminal angle that's on your unit circle. 3 pi over 2, that is on your unit circle, okay? The ordered pair for 3 pi over 2 is 0, negative 1. So you can figure out easily, you know, what the sign is of 11 pi over 2. That's going to be your y coordinate and your cosine. That's going to be your x coordinate, and so on. Okay? Okay. Don't think I finished this one up right here. Sorry about that. Like I had an interruption and I lost my train of thought. Anyway, getting back to this one, cotangent in the second quadrant is negative, right? So you have to make sure that you put your negative sign there, and then cotangent is y divided by x, so this divided by that, the 2's would cancel and you're left with square root of 3 as your answer. Okay? Alright, last few examples here. This is kind of going backwards. It says find the values of theta if you know the degrees and the I'm sorry, if you know the trig functions. So here, if you look at these equations, it says the cosine of theta is square root of 2 over 2. We have to find theta in the first quadrant, because notice our domain here, 0 to 90, and 0 to pi over 2. So they want two answers. They want one in degrees and one in radians, okay? So notice that for this problem, because of our domain, look at these inequalities and look at them carefully, we can only be in the first quadrant. So we're only looking for first quadrant angles here, okay? So if you just go to your first quadrant and look at your unit circle, the angle that has an x coordinate of the square root of 2 over 2 happens to be our 45-degree angle in degrees. But they also want it in radians, so that would be pi over 4. And that's all you do, okay? Here, for tangent of theta, and this is why you really need to know that first quadrant of your unit circle very well, okay? Then you need to know that when tangent is a positive or a negative square root of 3, then that would be your 60-degree angle in degrees, or in radians, it would be pi over 3. Okay. Now, for secant, what I like to do is I like to change that to cosine. So if I change secant to cosine, because I think better in terms of sine, cosine, and tangent, then if I flip that, then I am actually looking for an angle whose x-coordinate is square root of 2 over 2, and that's actually the same one as this one, isn't it? So again, theta is going to be 45 degrees, or in radians, it's going to be pi over 4. So I always change secant, cosecant, and cotangent. I flip them and take them back to sine, cosine, and tangent. All right, now notice here, same kind of problem, but you're looking at the whole unit circle this time. You can go all the way to 360 or all the way to 2 pi. Notice these inequality signs don't include 360 as your answer or 2 pi as your answer though, okay? So from 0 all the way up to, but not including 360 or 2 pi. So here, I've got sine of theta is 1/2. Well, it's a positive 1/2. That means I'm looking for a first quadrant and a second quadrant. And I get that simply by remembering ASTC. That all my trig functions are positive in the first quadrant. Sine is positive in the second quadrant. And then just tangent is positive here in case sine there, and their inverses. Okay? So I'm just thinking, well, what first quadrant has a y-coordinate of 1/2? That would be 30 degrees. Well, what second quadrant angle has a sine of 1/2? And that would be 150 degrees. So you got to know that unit circle. And then, of course, you've got to know their radians. Okay? So this one will be pi over 6, and this one will be 5 pi over 6. Okay? Cosecant here, again, make sure that you realize which quadrant that you're, where cosecant can be negative. Oh, and again, you can flip that. Let's make it sine first, that'll be easier. Rationalize that denominator. That's going to be 3 times negative 2 is negative 6. That 3 and that negative 6 will cancel. So I'm actually looking for where sine has a negative y coordinate of negative square root of 3 over 2. So sine is positive in the first and second quadrants. That means sine has to be negative here. So we're looking for two angles in these two quadrants that have a y-coordinate of negative square root of 3 over 2. And in degrees, that would be 240 and then the other one would be 300. And 240 as a radian is 4 pi over 3, and 300 is 5 pi over 3. So again, how am I doing this? Well, easy. I know my unit circle, and I know it well. So you're going to have to memorize your unit circle. Okay, last one here. Cotangent, again, I like to change everything back to sine, cosine, and tangent, but the reciprocal of -1 is -1. So I need to figure out, well, where is tangent negative? Well, I know it's positive in the first quadrant and the third quadrant by ASTC. Okay, so this is where it's positive. That means it's negative right here. So I'm looking for a second quadrant and a fourth quadrant angle whose tangent is -1. Keep in mind that tangent is y divided by x. So you're actually looking for your x and y coordinate to be opposites of each other. So, because they're going to divide out to give you a -1. And that's going to happen at 135 degrees and at 315 degrees. And in radians, that would be 3 pi over 4 and 7 pi over 4. Okay, so have fun with this. Learn your unit circle. You've got to know it. Why? You have to know your unit circle because you will have no unit circle on quizzes and tests, and you will have no calculator on quizzes and tests. So you've got to know this stuff and know it very well.